Alright, so next we'll be putting our raw and processed data with appropriate number of significant figures, and of course not to forget our decimal places. So remember, for this video, I believe will be the most important one, because this is where the majority of the marks will be given. Okay, so they will look at, hey, how many SF you give me, how many DP you give me. So if you give them wrong SF, wrong DP, they will not award you the mark. Alright, okay, so first of all, what is raw data? So raw data is basically our length. So the length we measure, right? The timing, the time. So when we are dealing with length and timing, it's important to follow the position of your apparatus. So if your, for the example of stopwatch is the position is around 0.01 second, right? So whenever you write the timing, so let's just say you write maybe your timing is 20 seconds, exactly 20 seconds. So you cannot give 20 seconds. You cannot put 20 then put a second here. You must give me 20.00 second. So they will look up, they will specifically look up for this kind of thing, right? Right? So example, you are using a meter rule. So a lot of students, they just put, let's just say you measure something 10 centimeter. So they just put this. So please do not put this. So you must put 10.0 centimeter. So this one is the correct one. Okay, so whenever we are taking the average, right? So example, average timing or average length, it's still a raw data. So average time is a raw data. Average length is also a raw data. So whenever you're you are getting the average timing or calculating the average length, please give them the precision of the apparatus. Okay, next will be process data. So what is process data? Process data can be something like, okay, so let's just say I use length, right? Then you multiply by your so-called timing. So this itself is a process data, because this process data is involved two raw data multiplying together or adding together. Right? So what should we do when we are dealing with process data? So example, you are multiplying or dividing the two raw data. To get your process data, you follow the least number of significant figure. So for multiplication and division, follow least SF. Okay, so later I'll do some example to further deepen our understanding. So the second will be addition or subtraction. So I can also use length plus your time, right? Or length minus timing, something like that. So this one we follow the least number of decimal places. Alright, so let's look at this example. Okay, so the first example, addition, right? So you can see I have four things or four raw data. So, okay, addition, we follow the least number of decimal place. So look at the first one. The first one has 1, 2, 3, 4, 5, 6. 6 DP. The second one is 2 DP, right? The third one is what? Even worse. 1, 2, 3, 4, 5, 6. 6 DP. The last one is around 4 DP. Okay, so apparently, our final answer, we must give them least DP, right? Least DP means the minimum number of DP, which is 2 DP. So you calculate first. So let me just calculate. Okay, so I get roughly around 24.61489. So please don't give them this, because you're not following the number of decimal place, right? So you just give them 24 point, you want 2 DP, right? So it's 61. So this is how you give them, right? Okay, example 2, I'm doing our addition again. So okay, so let's put in the DP. So the first one will be 1 DP, second one is 2 DP, third one is 2 DP, and last but not least is 3 DP. Of course, our final answer must be 1 DP. So let me just calculate. So okay, in my calculator, I will get roughly 156.841. So I convert to 1 DP only. So 156.8. Right, so it's 1 DP. This one is 2 DP. Alright, so when you are when you are dealing with addition and subtraction, follow the least DP. Okay, what if you are dealing with multiplication? So something times something, right? Okay, so same thing for multiplication, we follow SF, significant figure. So for the first one is 2SF, right? The second one is 3SF. So just give me 2SF. So in my calculator, I get roughly 9.552. So this is for SF. So cannot give them for SF. You must give them 2SF, right? So 9.6. So this one is 2SF. But of course, if you want to give them one more, it's okay. So means that you can give 2SF or 3SF. That one is okay. Alright. So you can also give them 9.955. So this is 3SF. But of course, to keep everything in the simplest state, we just follow the least SF. Okay, number 4. Example 4 will be divide, right? So divide, same thing, follow the least SF. So this one is 3SF. This one is 4SF. So you must give me either 3SF or 4SF, but just give them 3SF. So 4.56 divided by 3.907. So you will get roughly 1.1671359. Right? So I'll give them the list. So it's 1.17 like that. So this is 3SF. Alright, so this is how you do your division. Okay, the example 5 is very important. Example 5 and example 6. Because now instead of multiplying or dividing with two raw data, so example, two raw data is something like this. This and this. These are raw data. But now for example 5 and example 6, we are dealing with constant. So 20 here, 1 here. So how do I do this? Okay, so if you look back at this, we always, when we are doing our division, we always follow the least SF. But if you are dealing with constant, we do not take into account of the number of SF of the constant. We just look at the raw data. Okay, so example, you are calculating 20 oscillation, right? So this is 2.52 is the timing, or the average timing, doesn't matter. So 20 is the number of oscillation. When you divide, you might give them, because 3 SF, right? You divide by something, 20 is actually 1 SF. So when you divide, you might give 1 SF only. Please don't do that, because this is a constant, so we do not take into account. Right? So okay, then we just follow the 3 SF, because this is 3 SF. So 2.52, you divide by 20. So you roughly get around 0.126. So you must give them 0.126 seconds. So this is how you do your 20 oscillation period. Okay, the last example will be 1 divided by length, or the inverse or the reciprocal of your length. Okay, so I can also put this 1 over length as this, right? L inverse 1. This is what we call the reciprocal. A bit of mess already. Okay, so 1 divided by length, same thing. Your length is a raw data, but your 1 is actually a constant. So if you use 1 divided by 20.0, let's just say the length is 20.0 centimeter, we always follow the 20.0, because 1 itself is a constant, so we don't follow that. So 20.0 itself is 3SF. Okay, so 1 divided by 20, so it's roughly, you must give 3SF or 1 more for SF, doesn't matter, but for me I'll just put the least one. So okay, if you sub your calculator, you notice you will get 0.05. If you put 0.05, that one confirm wrong. Okay, so you must give me 0.05. So this is 1 SF already, right? You put 2 more, 0, 0. Because the 0 behind your 5 is considered as a significant number. In front is not. So the 0.0, this one is not SF. Okay, so that's how you present your data accordingly.